record button. The lecture is being recorded. In this lecture, I will do some questions from chapter 16. Then I will open the ground up for any possible questions from students. Okay. Can somebody confirm you can see my screen? Okay, thank you. So I'm going to do some questions from chapter 16. Okay. The first question, a contract is estimated to yield net annual return of 31,500 for 8 years. To ensure the contract, an immediate outlay of 155,000 is required. Rate is 12% compounded annually. Compute net present value of the contract and determine whether the project should be accepted or rejected according to net present value criteria. So first, we need to know what is the net present value. So by definition, net present value equal to present value of cash in minus present value of cash outflow. Okay. And in this example, what is the present value of cash outflow? Present value of cash outflow, it is the outlay of 115,000. So that number we know. So we just focus on what is the present value of cash in. That number is the present value of annuity. The present value for annuity, that annuity is 8 years. That is present value for cash in, then minus present value of outflow, 155,000. Okay. And now, for the first part, we can use formula, then we can use calculator, because this lecture has a review purpose, so I'm going to use both. Okay. So the present value maybe I will try to. It is equal to PMT, present value for annuity, and then 1 minus 1 plus I raised to power negative n over I and I is 12%, n is 8, PMT is 31,500. So you have every number in this formula. Then you plug in, you can get the present value of the annuity. Okay. So this is formula method. And for calculator method, how do you calculate present value for the annuity? So I'm going to second quit to clear anything. You need to make sure your computer is at the end mode. So you go to PY, second PY. PY is 1, enter. Down arrow key, CY is 1 because interest is compounded annually. So second quit. After that, you enter PMT, 31,500. This is negative number. So this is the PMT. Okay. And 12 is IY, interest. 8 is a year. You entered 3 numbers. Remember, you need to enter 4 numbers. So don't forget 0FV as precaution to clear any previous entries. Final step, compute PV. Compute PV. Okay, and you get this number. And then you use this number minus 155000. So minus 155000. And you get net present value 1,408.65 cents. If the question asks you to round to nearest dollars, it is $1,481. Okay. So we answered the first question using 2 methods. One is formula, and the second is calculator. Okay. There is another question. Should the project be accepted or rejected? If NPV greater than 0, you accept the project. If NPV smaller than 0, you reject the project. Okay. So that is the NPV. There is a third method using Excel NPV function. So this is the one I'm going to turn to. Okay. So I'm going to open an Excel. I want to use Excel to calculate NPV. Okay. To use Excel, you need to arrange the data usually in one column. For example, column A. Okay. And the cash flow is an outlay, that is the negative number. So negative 155000. That is the negative cash flow. And then you have a positive cash flow, 31,500. And this number occurred 8 years. So you copy down so that this number occurred 8 years. Okay. After that, the Excel has a NPO. Is this 8 years? Yes. No. Okay. So now you enter the formula. Type in equal NPV, opening bracket, just adjust my screen. And then the value, you use all the number except the initial outlay, closing bracket, and then plus the initial outlay. That is the formula. So press Enter key. New argument. NPV. Oh, rate. I have to enter the rate. So equal NPV. Rate is 12%. Then comma. Enter those numbers. Okay. And then plus initial outlay. No. This one should be A1, A2 to A9, A2 to A9. So I pause moment to show you the formula. The number give you the percentage. You format this percentage to number. So format cells. Quick number. The requirement of the question said, round the final answer to nearest dollar. So decimal place is 0. So you get 1,481. It is the same number as we get from here. All right. I also posted the formula here in Excel. Okay. So 3 methods to solve NPV. 1 method, use definition formula. Second method, use financial calculator. Third method, use Excel. So this is this question. So this question here, question 2. An engineering company normally expects rate of return on 11% on investments. 2 projects are available, but only one can be chosen. Project A requires an immediate investment of 6,000. This is a cash outlay. In return, a revenue payment of 4,100 will be received in 4 years, and a payment of 10,500 in 8 years. So that is project A. For project B, require an investment of 2,100 now and another 3,000 in 3 years. In return, revenue payments will be received in the amount of 1,000 per year for 8 years. Which project is preferable? So for this question, you calculate NPV. The bigger the NPV, the more preferable. So you choose the bigger value of 2 projects that has NPV, net present value. Okay. So I'm going to theoretically you have 3 methods. 1, use a formula. 2, use a calculator. 3, use Excel. Okay. Out of these 3 methods, Excel is more convenient because you can access Excel anywhere. Formula you may forget and you may look up it into the textbook. And for the calculator, maybe your calculator is not on hand. So I strongly recommend you can use any of them. Okay, so here for demonstration purpose, I will just use Excel because it is convenient, it is easier. So first I will explain how do I set up Excel. Well, maybe hide this one. Okay. So I'm going to do project A, then project B. There are 2 projects. So project A, I use red color. So we write down some numbers. Require immediate investment of 6,000. Investment means this is money outflow, so negative 6,000. A revenue of 4,100 will be received in 4 years. Okay, so 4,100 in 4 years. This number appeared 4 times. Year 1, year 2, year 3, year 4. And a payment of 10,500 in 8 years. Revenue. A revenue payment will be received. No, this is not every year. It is just one time, just in year 4. So year 1, year 2, year 3, year 4. Okay, this is in year 4. 5, 6, 7, 8 in year 9. In year 9, you'll receive 10,000. 500. I don't want decimal place. Moment sales, 0 decimal, and the number without dollar sign. So this is the project A situation. Now project B. B require an investment of 21,000. This is negative number, money outflow. And another 3,000 in 3 years. In return, the revenue will be received amount of 1,000 per year for 8 years. So you will receive 1,000. This number will occur 8 times for 8 years. So you received 1,000 for 8 years. Okay. But you need to invest 3,000 in 3 years. This is year 1, year 2, year 3. So this number, at this point, you have to invest 3,000. Although you get $1,000 in, you have to put 3,000 out. So the net effect is this number. You have to subtract 3,000 because there are investment 3,000 in year 3. So in year 3, you get this number. Okay. The interest is 11% for both projects. Okay. So now I'm going to calculate the NPV equal NPV opening bracket 11%, comma, typing all this value, then plus initial outlay. So this is a net present value for project A. You repeat yourself, you can get project B. Okay. Project B equal to NPV opening bracket value is here, and then plus initial. So obviously you should choose project A. Okay. So this is a question 2. So next, I will do a question about IRR. Can you hear me now? Okay, not sure what happened. Okay. Thank you for your feedback. So now I'm going to use calculator as you suggested, okay? Okay, great. Thank you, Natasha. Okay. So I need some, okay. So for calculator, we need to do what is NPV for project A? What is NPV for project B? Okay. Okay. Project A, I will use red color. See, everything I use red color. So project A, the calculator, we need to calculate what is present value of money in, cash in, and then minus the present value of outlay. So we are doing project A now. Okay, project A. Money in is just, there are two times happened in money in. One is 4,100 in 4 years. The other is 10,500 in 8 years. We need to add those two values together in terms of present value. Money out, it is just this 6,000. Okay, so I'm going to write it down. So money in, it is the present value for 4,100. What is the present value for 4,100? And what is the present value for 10,500? That is money in, two streams of money in. Money out, it is just 6,000. Clear? All right. So this is, now we can use calculator. So second equation. Okay. This money in or money out, it is happened every year. It happened in years. So PY is 1, CY is 1. Double check. PY is 1, CY is 1. Okay. And then you need to calculate the present value of 4,100. Oops. Present value of 4,100. So you do this. This value is future value, 4,100. This number is FV. This number in 4 years, 4 is N. Interest is 11%. You need 4 numbers. Okay, so 0 is PMT. Then calculate PV. So this present value is negative. It should be positive. You should enter. I'll double check. Clear. This is 4 years. 4 is 11 is IY. 11 is IY. 0 is PMT. And future value, you should enter negative number in order to get positive. That means 4100, that is the future value. Compute present value. Okay, future value enter negative, you can get positive, but now I will write down this is 27.79. So this is the present value for 4,100. Then calculate the present value for 10,500. Use calculator. Okay. So second equation. So this is 8 years. In 8 years, 8 is N, 11 is interest, 0 is PMT. It is 10,500. So if I enter negative number, this is future value. 0 is PMT. Compute present value. I got 4556. $4556.23. Okay. And then this number has to minus the money outlay, 6,000. So now you are going to do this number plus 27,000.79, then minus 6,000. So this is the number. So this is project A. Okay. And for project B, you use the same formula for NPV, net present value. For project B, net present value equal to it is money in, so it is the present value of an annuity. Present value of annuity of 1,000 per year for 8 years. This is money in. Present value of the annuity minus the immediate outlay is 21,000, and then you invest 3,000 in 3 years. So the present value of 3,000 in 3 years. And now, what is the present value of the annuity? $1,000 a year. So second equation, this is annuity. 1,000 is PMT, $1,000 a year. Okay. And then 11 is interest. It is for 8 years. 8 is N. Okay. 0 is PV or FV. Then compute PV. Okay. So I'm going to store this number here. I need to use this number later on. Okay. And also I did better write down here. Now I'm going to calculate what is the present value for 3,000. The present value for 3,000 is 3,000 is the future value. 3,000 is the future value. 0 is PMT, 11 is IY, 3 is N, compute present value. Okay, so present value 2193. Okay, so now I'm going to do this one here. So I'm going to store this number here. So this number should be, and then I'm going to recall this number. So this number minus 21,000, then minus, I stored number here. It is this number. No, I didn't. So I'm going to redo it. So 5. Equal 1. This number minus 21,000, then minus 1, 2, 3. It is 852. So I calculated the net present value. Okay. So then you compare net present value project A with project B. Of course, you prefer project A. It has a bigger NPV, 1,257. Okay. So that is the net present value. Any questions? So I'll check the questions.